help a lot.
Nice, isn't it?
They're in the library for like a couple doors.
Good. So this is going to be questions on 8.3. Actually, I'm just going to do your questions. I already did a lecture on there. If you guys noticed, I already uploaded one. Okay. So this will be a little more intensive because you've asked more questions. So 8.3, testing claims about 8.2. Testing claims about proportion. So we've asked two. It says the null and alternative hypothesis. Make sure you guys can see this. So the null and alternative hypothesis, it says identify the null hypothesis and the alternative hypothesis. So I guess I have to read the stuff here. So in questions 1 through 4, use the results from USA Today survey in which 510 people chose to respond to the question that was provided on USA Today website. Should Americans replace passwords with biometric security? Amongst the respondents, 53% said yes. We want to test the claim that more than half of the population believes that passwords should be replaced with biometric security. Okay, so what they're asking in the first 4 is kind of trying to get you guys to set up like the first 4 steps of a hypothesis test. So let's just kind of talk about the information first, because if you're going to do a hypothesis test, the first thing you really identify is the claim, right? So what's the claim? It's in here. So it's usually with the sentence that has the word claim in it, right? So it's kind of nice is you can identify it relatively quickly. So it says we want to test the claim. So test the claim that more than half. So what does more than half mean? Yeah, P is greater than 50%, right? So that's really the claim. So that's what they're looking for, more than half. So let's just kind of go through the first 4 questions. So identify the actual number of respondents who answered yes. Well, the actual number of people that responded yes was this 53%. And we usually live in decimal land, so this would be 0.53, right? Because we have to plug these things in the formula. So 0.53 answered yes. Identify the sample proportion and the symbol used to represent it. So, well, that's what it is, right? It's the same thing. The sample proportion is the actual number of respondents, right? So, number 2 says the null and alternative hypothesis. Well, the null hypothesis is always the one with the what? How do I? Yeah, it's the one that has the equal sign. So let's kind of write up there what they've had so far. So 8.2 testing proportion. So what they said is they want to test the claim that the claim is more than half proportion. Is more than half. So what they say is that P is, so this is basically step, this is step 1. Step 2 is, yeah, write it in symbolic form. So this would be P is greater than 0.5, right? What's the opposite of this then?
Equal.
Less than or equal, right? Or it would just be equal. You guys agree that sometimes they just get rid of the less than or equal. They say, well, just let that one be equal to 0.5. Now, depending on the book, some books use this, some books use this, okay? I think this book used the equal sign. And I think it makes mention in the book as well, that's just what it is. So number 3 would be, what's our null? What's the null hypothesis? Is it the top or the bottom one? Yeah, it's the one P is equal to 0.5. So that means the alternative hypothesis would be P is greater than 0.5. Agreed? Okay, so let's finish the question. So that's what they asked to do, the null and the alternative hypothesis. Number 4. Number 4 says, are any of the 3 requirements violated? Can the methods of this section be used to test the claim? So when we're testing proportion, we have to make sure that there's this normality check that n times b n times p is greater than 5, and also n times q is greater than 5. It's the exact same normality check that we had to do when in 6.6. You guys remember that? When we were using a normal to estimate a binomial.
Yeah.
So if it was appropriately, if it was smooth enough and bell-shaped enough, then we could actually use that normal curve. So this has the exact same requirement. So n is 510, right?
Mm-hmm.
And p is 0.5.
Yes.
So that's clearly bigger than 5, right? 510 times 0.5 is bigger than that. Also, well, that's p. If p is 0.5, then q is 0.5. So number 4, are we good? Sorry, I kind of have this all messed up. This is question 2. That's question 2. I was just kind of working through how we test a claim. Question 4 is asking for, are the requirements satisfied? Well, it's hard to check to see if something is a simple random sample. That's like the first thing they say, right? Sometimes we just have to take their word for it. Let's see. USA Today survey. I don't know. I'm not sure if it was a good survey method, so I'm not sure if it's a simple random sample. Next, we have to see if n times p. So n is equal to 510, p is equal to 0.5, so q is also equal to 0.5. So when we do the normality check, n times p would be equal to 510 times 0.5, which is what, 255? Which is definitely greater than 5, right? So that was good. And then I also have to do n times q, which is the exact same value, right? Because q is the same, 0.5. So this is equal to 255, which is also greater than 5. So boom. Remember, the reason why we have to do this is remember I'm drawing pictures that look like this. We're using a bell-shaped curve in order to estimate these things, right? We have the tails. Let's just say we have a two-tailed here, and we know the null lives there, right? Remember, I'm using a normal curve, and a normal curve is a continuous distribution. That means there's infinitely many values. You guys agree? But if I'm talking about a survey with just 510 people, is it really continuous? It's discrete, right? So we're using a continuous curve to estimate a discrete probability. So that's why we have to have that same normality check that we did in 6.6. Okay. Number 9, making these. Okay, so let's test some claims. So on the test, I'm going to ask you guys to test claims. I'm going to give you one that's two-tailed, one that's left-tailed, one that's right-tailed, okay? So you guys will see one of each. And sometimes I'll ask you for the proportion, sometimes I'll ask you for the mean, and sometimes I ask you for the standard deviation or the variance to test claims about that. So you just have to use the correct formula, which is nice because our formula sheet has that. Mickey D says... All right, so number 9, the study of accuracy of fast food drive-through orders. McDonald's has 33 orders that were not accurate amongst 362 orders observed. Use the 0.5 significance level to test the claim that the rate of inaccurate orders is equal to 10%. Does the accuracy rate appear to be acceptable? This is something they actually McDonald's could do. You could take a sample.
We do this.
You do, don't you? That makes sense. Okay, yeah, this is something that makes sense that you do that.
We do that every day.
Yeah, that's fun, isn't it? Did they make you draw the curve? No.
We do a histogram.
I gotcha. You could actually be a little more accurate then. We can kind of show them, because this is how it's done. Okay, so what we know is, in order to test the claim, so number 9, show them in frame here. Number 9, we have to kind of go through steps 1, 2, and 3. So step 1 is kind of identify the claim, right? So what's the claim? I know you can't see it. What's the claim? So there's the word claim, right? So it's got to be somewhere around there. You guys agree? So claim that the
Inaccurate orders is equal to 10%.
Okay, so the claim is I'm not writing it in words, okay? P is equal to 0.10, okay? They say to write it in words. You guys don't have to. Just write an equation. It's so much quicker. So number 2, really asks you to put that in symbolic representation, which I technically already did. You guys agree? Like that symbolic representation of the words? Okay. So symbolic representation and then also the opposite. So yeah, P is equal to 1.0. So my bad, I should write it this way. So this is going to be the claim, and this is going to be the opposite. So the claim is P is equal to 0.10. So that means the opposite is going to be P is not equal. Okay, so now we have to go to number 3, and you have to determine what one of those are the null and what one of those are the alternative. So looking at the null, looking at the alternative. What one of those are the null?
Top.
Yeah, because it has the equal sign, right? So the null is the top. And then the alternative is the bottom. Now remember, the alternative tells us our tails, right? How many tails is this? 1 or 2? So I'm going to go down to 4, 5, 6. So let's explain why this is what it is. So when we have this bell-shaped curve, we know that the null is going to be here. And it says that I have a, oh, I just gave it away. Oh well. So we know that the null is right here. This is going to be is going to be the equals part, right? So what's considered not equals? Well, not equals is going to be far too big or far too small, right? So out here is going to be the not equals. If you were only testing greater than, then I don't care about this side. Does that make sense? So greater than, it would just be a 1 tail on the right side. And if I was just testing less than, it's going to be a 1 tail on the I think I said that backwards. Greater is 1 tail on the right side, and less is 1 tail on the left side. So since we're testing equality, not equals means too small and too big. Actually, in programming language, this not equal sign used to be written like that. And this is a less than, and this is a greater than. So this is a greater than, this is a less than symbol. Because that means it's both this and this. That's what not equals mean. Okay. All right. So this means 2 tail. And the tails are always, alternative tells us that. All right, number 4, what's alpha? Yeah, 0.05, right? Alpha is equal to 0.05, 0.05. Since it's 2 tails, am I going to use alpha or alpha over 2? Alpha over 2, that's right, I'm going to use alpha over 2. So that means this tail right here is 0.025, and this tail over here is 0.025. And this is going to be our null, right? So this is 0.025. Now, we'll have to figure out these critical values here. This is what we're going to do on step 6. A lot of times I was doing it on step 4. It doesn't really matter. We have to eventually put them in there. All right, number 5 says, you know what? I'm doing it now. We got all the information. So these critical values right here are these axis values, right? And the axis value is, this is a t-axis. No, I'm sorry, this is a z-axis. So that means this number right here is going to be z of alpha over 2, right? And since we have a 2 tail, this is going to be negative that exact same number. So all I'm going to do is locate this value, and then I know that this one's going to be the opposite of that value. So I have to go to a t-table. Sorry, z-table. Okay, so using a z-score, what I know is I need an area of a tail to be 0.025. So remember that z-tables are cumulative area to the left, right? So what's the area to the left of this number? Yeah, 975. Yep, because it's 1 minus this number, right? Because this all adds to 1. You guys agree? So 1 minus this number is going to be 0.975. So what I'm going to look for is, now again, I'm talking about this plus this essentially, right? So that's going to be 975. So looking at 0.975, which is, here's an exact number, right?
That one's on the bottom.
Should be right here too. So it's going to be 1.96. And you're right. Actually, she has it. You guys notice that 975, which is right here, tracks to 1.96? Look down here. Common critical value. So if you have a confidence level of 95%, well, your critical value is 1.96, right? What they mean by a confidence level is if alpha is equal to 0.5, then clearly in the middle is 95%. So this is equal to 1.96. So those are shortcuts, but I don't always ask those values, so you have to know the other one. So this number is going to be negative 1.96. Okay. Number 5, we have to do our test statistic. Our test statistic is the representative. It's a z-score that represents the sample. So these things right here are what are considered like our critical areas, right? If you live in here, you're clearly not equal because you're too small or too large, right? So what I need to know is I need to know if that 53%, I'm not 53%, but that whatever their sample actually is going to live in the null, or if it's going to be too small or too large. So our test statistic is z is equal to p hat minus p all over the square root of pq divided by n. So what I'm going to need is, over here I'm going to write p hat. So it's all cocked. So this is p hat is equal to, because I'm going to have to put that in the formula so I know its value. So what it says is how do you find p hat? From here. That's right, yep, so it's going to be that number, 33 orders that were not accurate over the total orders observed, so 33 over 362. So 33 over 362 is equal to...
0.09.
I want to take it out a little bit. Is that exact?
0.09116.
Yeah, you're technically not supposed to round this number. You really are supposed to be as accurate as possible, okay? So I'm going to take it out a little bit. I'll take it all the way to 9916. To be honest, probably all the way to this number. 3 sig figs would probably be fine. Okay. So that's extremely accurate. So when I pop this into the equation, p hat represents a sample because anything that has the hat on is always a sample, right? Okay, so this is going to be 0.09116 minus, how do you find the value of p? Where does that come from? Yeah, that comes from what?
Claim.
It comes from the claim, yep. So this is 0.10. So remember, the denominator is all the numbers that come from the claim as well, okay? So p and q, so square root of p is equal to 0.10. So q is going to be, well, whatever adds it to 1, right? Whatever I'm missing from 1. And then all divided by n, and n is this 362. Just be careful if you want to plug this all the way in your calculator to put the numerator in parentheses as well. So I plugged just in just the exact way it sits in there. So what I get is I get negative 0.56. Does this number does that number make sense? Do you think I fat fingered anything, or does that seem right? Intuitively, I want to know. How can we tell if that number makes sense? All right, let's look at our sample.
Well, if you look at the graph, can't you just tell where it should lie?
Well, I'm going to pop it in there, but I want to know if this number makes sense compared to my claim. Well, remember my p hat, which is my sample? That number is pretty close to the claim, isn't it?
Yeah.
Is it above or below the claim? Below the claim, right? So as far as the z-score, should it be negative or positive? Should be negative because it's below, right? So remember, this right here is 0. You guys agree? That's the claim? Okay, so it better be below 0. Is it very far below 0? I mean, sorry, is it very far? Like when you look at the claim and you look at this number, are they that far apart?
No.
So remember, this number is not that far off of 0, is it?
No.
Okay, so it kind of makes sense to me. So we know is that sample value, this number right here, is right here. This is negative 0.56, which is this is z-score, so z is equal to that number. So the question is, does this z-score live in the null, or does the z-score live in the critical values? In the null. Okay, so do we reject the null or fail to reject? Fail to reject. Now there is some special wording that you're supposed to use. So what I'm going to ask you guys, Yep, it's all the way back in 8.1. If you guys mess this one up on a test, I don't think I'm going to be that worried about it, okay? So let's talk about
There's
the
no sufficient evidence to warrant rejection to the claim. Also
Yep.
claim that, you
what page is that? That's it's on 8.1, page what?
366.
366. So there's special wording that you're supposed to use, depending on what you get. So, in maybe the next statistics class might be a little more worried about this. So, what we have two different things. Does the original claim include equality, or does it not include equality? So look at the original claim. Does it include equality or not? Does it have the equal sign, or is the claim the not equals or less than or?
The claim is
Okay, the claim is about equals, right? So if we look over here, the first sentence says the original claim does not include equality. That's not true. The original claim does not include equality. Okay, that's not true. Aha, the original claim includes equality, and over here the original claim includes equality.
That's right. Yeah.
So I'm one of these two. You guys agree?
Yeah.
So now the next thing is, you reject a null or you fail to reject a null. What one did we do?
We failed to reject.
So it's the fourth one. So what we say is there is not sufficient evidence to warrant rejection of the claim. That is some horse crap. So, what does that mean, like, in actual words? I'm going to write it down because that's what they told me to. But I want to know what that actually means. So there is not sufficient evidence, to warrant rejection of the claim. I hate this so much. Okay,
You
so,
write your original claim for that, so-
yeah. So let's kind of go back and see what this means before I discuss this sentence here that they made me write. We reject the null, right? So let's go all the way back up here. We reject the null, which means we're rejecting. Damn it, I did it wrong. Sorry, thank goodness. We're failing to reject the null, right? So failing to reject the null means that we're accepting the null. Does that make sense? Fail to reject means you're good?
Accept.
Yeah, exactly. So I failed to reject, which means the null is good. I live in the null. You guys agree? I live in the null. So that means I'm failing to reject it. So my thing lives in the null, so I circled the null. Now we have to go back and we have to see what these things map to. Was the null the claim, or was the null the opposite? So, well, the null is the same thing as the claim, isn't it? So that means the claim is what? Is the claim correct or not?
Yes.
The claim is correct and the opposite is not, right? So, the claim is correct. So this is what they said. Not sufficient evidence to warrant rejection of the claim. So they're not rejecting the claim, which means they're accepting the claim, right? Sounds a lot like that wording as well. Okay. So if you guys just want to say there's sufficient evidence to accept the claim, I probably won't mark you wrong. All right? Is that clear? I do want you guys to know if the claim is correct or not, okay? It's the very last week of the year. If I had more time to get really good at this, then we'd care about it. Next. 17 and 23. 17. And we'll come back to that page a couple times. So that page right there where I learned the wording is table 8.3 and 366. So if you want the wording to match, then you use this table, okay? All right, 17 says births. It says, I can see good enough. It says, a random sample of 860 births in New York. The state included 426 boys. Use a 0.5 significance level to test the claim that 51.2% of newborns are boys. All right. I was hoping you guys would want, let me make sure the other one's not about equality. So you got 23 cell phones. Test the claim is different from the, do you guys have any one-tails that you have any questions on? Everyone you asked was a two-tail. Let's do a one-tail. That's what I would highly recommend. We just kind of beat the two-tails. We'll do more of these in a second here, too. So let me find one. Here, let's do number 15, okay? Just because it's a, and if you guys, anybody who asked 17 or 23, I'll be happy to do it after class, okay? So we're going to do one more of these, and then we're going to move on to the next section, okay? We're going to do a lot of this and get very good at it today. Okay, so number 15 says, in a study of cell phone use and brain hemisphere dominance, an internet survey was emailed to 5,000 subjects, randomly selected from an online group involved with ears. An emailed survey, huh? What do you think about that data? Yeah, I think so too. Oh well, we're gonna do it anyway, right? But okay, because remember that's now it's voluntary response, isn't it?
Yeah.
So it's probably not great data. Okay, so wait a second, but they did email 5,000 people. Does that help?
Nope.
Sure doesn't, right? Size doesn't matter, right? Okay, just because you get a lot of responses, they're going to be a lot of the same type of people. You guys agree? Okay, now what is it? Email to involved with ears. I don't know. Okay, so we're going to do it anyway, but I'm not. Whatever this is, it's junk. So, all right. So 717 surveys were returned. Oh my goodness, that is very voluntary. You guys agree? They emailed 5,000. They got a whopping 717 back. All right. So use a 0.1 significance level to test the claim that the return rate is less than 15%. Actually, this is not that bad because they're not actually testing. Data around the voluntary response. They're testing what is the response rate. This might actually be okay. Does that make sense? Okay. Whatever. We're gonna do it anyway. So use a significance level to test the claim that the return rate is less than 15%. Okay. So number 1. The claim is what? Yeah, 15%. I know I wrote it in words. So you said that the claim is in symbolic representation is P is less than 0.15. Yep. I honestly think you could just start at 2 and I'd be okay with that. So number 3, I want to know what is the null and then what is the, I forgot to write the opposite over here. So if the claim is less than 15%, what's the opposite? Yep, greater than or equal to. So we're just going to say equal, right? Do you guys agree it would be greater than or equal to 0.15? Okay.
So I can write like equal.
You
or
could-
I can write just like.
You could leave that if you want.
or Equal.
Yeah, make sure it has the equal. That's the most important
Oh.
part, okay? So I'm going to drop the equal when I put it over here, okay? Okay. So what one of these is the null? What one is the alternative? Is this the null or is this the null? The claim or the opposite?
Opposite.
Yeah, because the opposite has the equality, right? So this is going to be P is greater than or equal to 0.15. So the null has to be the other one, right? So P is less than 0.15. Remember this mapping, okay? We have to remember this mapping that this came from this. Oh, I'm going to drop that greater than. I'm just going to write this as equals. That the opposite is the null and the claim is the alternative, right? So when I circle one of these, the correct one, we need to know where it comes from. All right, number 4. What's alpha? 0.01. Thank goodness it's different. Okay. So 0.01. Am I going to use alpha or alpha over 2? Is this one-tailed or two-tailed? What tail is it? Left tail or right tail? Remember, it comes from the null. I mean, that comes from the alternative. What way is this pointing?
Left.
So this is a left tail. This is left tail. So when I draw this up, when I draw this up, we're going to have this bell-shaped curve here. And I know they're testing less than, right? And less than is way over here. You guys agree? So that's why this is the left tail, because less is this way, right? Okay. So that means, am I going to be using alpha or alpha over 2? This is the only critical area guy, by the way. And that critical area has to equal this number, right? The sum of the critical areas have to equal this number. And since it's only one tail, this is going to be alpha over 1, right? Which is going to be equal to what area is in here? 0, 1, 0, 1. Okay, so if it's two-tailed, you're going to cut this number in half, right? But if it's one-tailed, you're going to leave that, and you're going to keep that number. Okay. So that means I need to find a z-score. Is this going to be z alpha over 2 or z alpha? Is it negative z alpha or is it positive z alpha?
Because we're not, it's just gonna be z alpha, and then we cut dividing by 2.
That's right, but is it going to be negative z alpha or positive z alpha?
Should be negative.
Yeah, because 0 is right here, right?
Yeah.
Okay, so this is negative z alpha. So we'll have to ask ourselves that. Alpha or alpha over 2? If it's alpha, then you have to ask, is it positive z alpha or is it negative z alpha? It's negative if it's a left tail, it's positive if it's a right tail. Because this is positive, the other's over here, right? So whatever, we might as well find that number right now. So remember that when you look at the tables, this says cumulative area to the left, right? So what's the area to the left of this critical value? Yeah, I got it labeled, don't I? Yeah, it's 0.01. Remember, if it was over here, you'd have to take this plus this, right? Okay, this just happens to be easy because it's left-tailed. So I'm looking for 0.01, so I'm going to be over here. 0.01 is, well, that looks close. Oh, there's the closest number. I don't know if you can read it, but it's, like this one says 0.102, which is dang close. But this is 0.0099. This is only 1 unit away. You guys agree? And this is 2 units away?
Yeah.
Okay. Units as far as the fourth decimal place. 1,000. So, oh, I didn't point it out. So my 0.99 maps to what z-score?
Negative 2.3.
Negative 2.33. Negative, so this is equal to negative 2.33. All right. Now I need to find my test statistic. My test statistic is a z-score that's going to live either in the alternative area or it's going to live in this null area, right? So z is equal to p hat minus p all over the square root of p q divided by n. I need to give myself more room next time. So I need to figure out what p hat is. I'm going to do it over here on the side. So p hat is the sample proportion, right? And we know that 717 were returned out of what?
5,000.
So that p hat's going to be that 717 over 5,000. This book does a pretty good job of getting you ready for this section. You know, this was a question that would be on like a previous test, right? What's the proportion of people? So you kind of have to know how to do that. So 0.1434. Okay. So now we plug that in. So the first number is my test statistic, 1434, minus what's p come from? The claim. So 0.15. All divided by, and all these things are the claim. Remember, this is PQ as opposed to not. So this is P, which is 0.15, Q, which is 0.85, all over N, which is going to be equal to that total, which is 5,000. It's a little different than confidence intervals. Confidence intervals you center around the around your test area, around your sample. In testing claims, you center around your claim. If I have time in our extra credit, next on Thursday, I'll show you a two-tailed version of one doing a confidence interval and one testing the claim to show you how they're the same. But if we don't have enough time, it's something we can live without, okay? So when I pop this number in here, don't forget parentheses up here. It'll blow everything up. So 0.1434. Okay, let's talk about this before I get this number. Take a look at the test, the sample statistic of proportion.
It's below, so it should be a negative number.
It's going to be a negative z-score. Is it very far? Is it much different?
No.
Okay, so the z-score probably won't be that negative, right? So if you get like a negative 15, you did something wrong. Is that clear? So I don't know. It could be anywhere from like, because it's kind of dependent on this denominator as well. This denominator is tiny, right? Because of this 5,000. So that means that if I divide by 5,000, it means this number is small. And if this number is small, then this number could be big. So distance, when we're talking about distance away from 15, it has to do with, its difference as well as the standard deviation, right? Like what we're considering a unit, what we're considering length. So I know it's going to be negative. I know it's not going to be a lot, but it could be below negative 2.
Negative 1.3069.
Oh. What? Okay, what'd you get, Sky?
Negative 1.3069.
Did everybody get negative 1.3069? Yes? Okay, thank you. Negative, 1.3.
3069.
Okay, so 3.1. Okay. The reason I'm stopping at 100th is because it's a z-score, and all z-scores are basically hundreds. So this negative 1.31, which I knew was going to be below because this number is below the claim, and I knew it wasn't going to be that far different. Is it in the null area or is it in the alternative area? It's in the null. So, so this z-score right here, the z, which is equal to negative 1.31, is going to be, it's clearly between these two numbers, right? It's between negative 2.33 and 0. It's not quite big enough, so it's probably like, it's about right here, isn't it? So this is negative 1.31. That's that critical, the test statistic. So does it live in the null or does it live in the alternative?
The null.
So do we reject the null, or do we fail to reject it? Yeah, because we're accepting the null. You guys agree?
Yeah.
So we're going to accept the null, fail to reject. Okay, now let's go back to, no, we write this in a sentence. So,
There is no sufficient evidence to warrant rejection of the claim.
so when we look at this, is the original claim include equality or does it not include equality? What's the original claim? Yeah, so does that have an equal sign on it?
Nope.
So it does not include equality. So when we're looking at this little table here, it doesn't include equality, so not include equality. So I'm either 1 or 2. Did I reject the null or did I fail to reject the null?
Fail.
So it's going to be the second box here, okay? So there's not sufficient evidence to support the claim. Not sufficient. I'm turning this. Sufficient evidence to support the claim. Now let's make sure that this is correct, okay? I want to make sure that this wording makes sense. So when I go back up here, I know that I'm failing to reject the null, so the null is correct because that's where I am, right? You guys agree I live in the null? So I'm going to circle the null. The null is correct, so I'm circling this. So if the null is correct, then the opposite is incorrect. You guys agree? Okay, let's map this back. What one's the null? Did it come from the claim or did it come from the opposite?
Came from the opposite.
It came from the opposite, right? So that means the claim is wrong. You guys agree? So is that what this says? Is the claim wrong?
Yeah.
Not enough evidence to support the claim, which means the claim is wrong. Okay.